The number of bacteria in a culture after a number of days from the start of growth is displayed in the table below. So we've got D, that's the number of days, and N, the number of bacteria. And just note here that the D is in the top row, so those will be our X values. And you can see that this axis is now a D axis for days. And the N is where the Y-axis is, that's the vertical axis, and you can see that this is the N axis. So we've got to plot these points. So we've got 1, 5,000, which will be just there. We've got 2, 9,000. 3, 13,000, so it's 10, 11, 12, 13. 4, 17,000, so 15, 16, 17. And 5, 21,000. Do the points form a straight line? Well, they seem to, so let's draw a straight line through them. And that would go like that. And normally you would just pop an arrow on the end, although we can't guarantee that's the case here. So if growth continues in this way, how many bacteria will there be after 6 days? Well, we could just project forward on the table, or we could use our graph. And at 6 days, when you use the graph, you should actually draw on the graph to show your measurement, like that. So we've gone up and across. So we'll say 25,000. For 10 days, we can't use the graph for. But we can see that these are going up every time by 4,000. So we can project forward. So 6, we've got 25,000. We just did that one. 7, we'd have 29,000. At 8, we'd have another 4,000. So that would be 33,000. At 9, we'll have 37,000. And at 10, we'll have 41,000. So that's going to be 41,000. Why is it unrealistic for growth to continue like this? Well, we cannot have an infinite number. It can't just keep on going up. There will come a point where there are just too many for the container that we're using, or whatever, for the amount of food we can give them. There'll come a point where they can't just keep on increasing in a linear fashion like that.